Hello everybody, my name is Mark Spevic, and in this video I'm going to teach you how to set up this more advanced burning tree effect. We will look at the networks in more depth in order to understand how to get control over the animation by using Microsolvers to add smaller details to the fire simulation. We will also look at splitting the fuel from the temperature to control when our object will burn. We will also look further at the shading and rendering in order to get the specific look that we'd like to achieve. So let's pop over to Houdini. Inside Houdini, if you load up the supplied scene, you will find a tree geometry, a basic setup of a Pyro simulation using just the shelf. We set it up using this flames button, and a shader for a basic setup for rendering. So what we're going to do is change the way that this behaves. The first thing I want to do is change the overall animation. So let's remind ourselves. I already have a flipbook of that animation, and let me press play. And we can see I quite like the way it's moving. And the best way to approach Pyro Sims, I believe, is to start off with the big shapes and try and then work into the smaller details. Get the overall big bits of your animation working properly first. So what I'm going to do is, with that animation, I wasn't really pleased with the speed of it. I thought it was going a little bit slow. Speed is a good sense of scale. The faster things are, the smaller they seem. The slower they are, the bigger they seem. In the movies, we actually overcrank things or overshoot things with a higher frame rate and play it back at a slower frame rate to slow things down and make them seem much bigger. So in order to try and speed this simulation up, because I want it to seem smaller, the tree, I'm going to select the Pyro Solver node. And at the top here in the Simulation tab, you'll find Time Scale. So time scale kind of speeds up the simulation. It's not like a time remap, but it kind of encourages everything to go a bit quicker. I'm going to change this to 1.3, which is 30% faster. And I'm going to flipbook that to see the result. So this should speed up things a little bit. I'll just pause the video while the flipbook happens. The flipbook has finished, and if I press play, I can see things are moving a lot quicker. I quite like that speed actually, and it makes this tree seem smaller, which is the aim of this. We can always retime it after we've cashed out the simulation, but it's important to get things to feel correct first. So I quite like the frequency of this and the frequency of the noise in the emitter. So the next thing to do is to actually go back to the emitter and to finish off the animation. As I mentioned earlier, I'd like to split up the fuel and the temperature. So the aim is that the tree is just hanging there, something hot comes past and the tree bursts into flames. So we want a bit more control over this. So how can we do that? Well, if we look where the inside the tree network here, we have the tree geometry, and we have this Pyro source node. If we middle click on it, it's creating our these attributes on the points, particularly the temperature attribute and the fuel attribute. If I have a look at the node, you can see it's creating fuel and temperature. So there's temperature and there's fuel. Next, we're adding noise to those values, and then this rasterize node is actually creating the volumes, the Pyro volumes for that. And you see we have fuel and temperature created here. And then we're outputting all of that to the sim. But we are in fact displaying the geometry because we don't need to display those volumes. So what I want to do is split this up. So I effectively want to turn that off. We can come to the create fuel node, and where it says temperature, we could either set the value to 0, or I could just click on the X here and actually remove it completely. If you have a look, we don't have that attribute. If I middle click on the bottom node though, we'll see that we still have temperature. That's because the add noise node is creating the temperature field here. Even though it doesn't have the attribute, it's still creating that field and adding noise values into it. So if I remove the temperature from here, I can now middle click on the bottom node and I can see I only have fuel. Let's see the effect of that on the simulation. If I dive inside the simulation network and press play, we'll see the box resizes and nothing happens because there's no temperature in there. But we have plenty of fuel. We can see that by using a visualizer. If I click on the smoke object and on the visualization tab, we can turn off the multi-field and turn on fuel. Oh, let me click on the camera, and you can see the sort of purple fuel that's still there. But if I click on temperature, the visualizer's round the wrong way. In fact, you can see there's many tabs here, one for each of the visualizers, and we have the options that we can change for them here. If I set this to YZ plane, we'll just see an empty grid, and there's no values in there yet. We'll come back in a minute to see if this is working. I'm going to leave that on for the minute. Back inside my tree network, I'm going to make an object that can be animated with temperature that will set fire to the tree. So for that I'm going to use a sphere. So I'm going to hit tab and type sphere. Let's make a little sphere. I'm going to turn this on but template my tree so I can still see it. And the sphere is a little large, so let's make this probably about 0.2, and let's turn this into a polygon. Let's up the division so it's nice and round. And I want to animate this, but I'm going to animate this using a transform node. I'll explain why in a minute. I want to keep the animation separate from the geometry. Now if I hit enter with my cursor over here, I can get the interactive handles and move it over to the side. And I'm going to control left click in the word translate to create keyframes on this frame. If I start dragging forwards, I'm going to be playing the simulation, which will be slow. So in order to set keyframes when you have a simulation in Houdini, I mean, for example, say I want to set a keyframe over here, you'll see it has to calculate all of those frames. I could turn off ghosting, but there's an easier way. If you come down to the bottom right here of the interface, you can click on the brain icon, and it'll turn to a red circle, and that means the simulation's disabled. And look, I can drag my slider anywhere when it's not having to update. And this is really a quick way, an easy way of adding keyframes. So I'm going to come to about frame 28, and again hold down Alt and left click on Translate to set the keyframe, and I can just test that that moves across. So this will be the temperature that moves across the scene. Don't forget to turn your simulation back on down at the bottom right here. So click back on that red circle and it'll turn back into the brain, and we're caching up the simulation again. Now what I'd like to do is turn this into a volume, and if we look at the network on the left here, you'll see that we have a Pyro source. So let's hit tab and type Pyro to get a Pyro source node. Let me plug that in. So what this does, it creates the points with attributes, and you can see from the at the top here, these are the different modes, and we've got the mode here keeping input, so it's keeping the input vertices of the geometry. What I want to do is actually change this to scatter in volume. Oh, let me see if the menu is working there. There we go. So volume scatter, and this will scatter the points in the volume. Now they're quite wide apart, and that's adjusted by this particle separation. If we make this smaller, there'll be smaller distance between them and therefore more particles. So we really want to fill the volume quite nicely, and 0.2 does that quite well. If we middle click, we see we don't have the attributes yet. For that we need to click on the plus, and then we can simply choose fuel. If we middle click now, you'll see that we have fuel. I don't want fuel in this case, I actually want temperature, so let me change this to temperature. The original value was 1.9. Let's stick with that so we have a similar look to what we started with. So now we have some points with the value of a temperature attribute with the value of 1.9. I don't want to add noise to this, I just want that to be a blob of heat. But I do want to turn it into a volume, and for that we'll use the volume rasterized from attributes node. So if you start to type volume attributes, there you go, you'll see volume rasterized attributes. Let's plug that in. So this will create a volume from the attributes we specify. So the attributes are fed in up here, so let's type temperature, because that's what we called it, and you'll see it creates a volume for the temperature. It's quite a coarse representation because it is voxel size. If we drop this down, you'll see we get a better representation. But I want this to be the same resolution as the other fuels volumes. So if I click on their rasterized node, you'll see their voxel size is actually connected to an expression. If I left click on the word voxel size, you can see the expression, and if you click it again, you'll see the value it resolves to. I'm going to right click on the word voxel size and do copy parameter. Now instead of copying the value, if I click on the volume rasterized attributes here, I'm going to right click on the same attribute voxel size, and I'm going to do paste relative references. What that will do, it will create a link between those two attributes. Now if I click on the word, you'll see it resolves back to the number. So if this one updates on the fuel, then the temperature one will update to be the same, and this keeps them in parity, and I quite like doing that. I'm also going to turn on normalized clamped average just to keep the values between 0 and 1 there. And you'll see we have our temperature sphere. And if I drag forwards, it's a little slow. I will turn off the simulation just to prove to you that it's still a little slow. It's a little slow because I'm having to evaluate this volume every frame. You'll notice there's a little clock icon at the bottom of your node. If you don't see that, you can tap D with your cursor over this network view, and you can click on badges. And you want to make sure the time dependent badge is on showing, either normal or large. So this means it's time dependent, so when anything upstream changes, these nodes have to evaluate. This transform node is changing every frame and forcing these guys to evaluate, and it's these guys that are slow. If we actually put the transform node underneath them and turn that on, you'll see this is the only time-dependent node now and not the others. So that means that none of these have to evaluate frame by frame, and as you can see the sliding is a lot faster even when it's animating. And it's usually a good idea to put your time-dependent nodes at the bottom here to stop the others having to evaluate every frame. So that's what that green tick means, it has to evaluate every frame. Look, if I just put this back up here again and turn the bottom node on, you see they all have to evaluate, and that's what makes it slow, whereas here just the one has to evaluate every frame, which speeds up the processing of the network. So those badges are a great way to help you optimize your network, plus always put your transforms at the bottom. That's another good tip. So we've got that working. What I'm going to do now is just hold down Alt left drag on this null, which will make a copy of it, and I'm going to call this one temperature. So now we have two volumes, one for the fuel and one for the temperature. I'm going to left click down here at the bottom left to turn back on the simulation. Let's go back to the simulation, and if I press play, we'll see we still have no temperature and no simulation. That's because I need to bring in that temperature. And to do that I use a volume source node, and we have one over here. If I hit tab and type volume, you can see I can create a volume source node. So let's plug that into the merge, and I'm going to also call this temperature at the end. Let's call it temp. So at the moment it's bringing nothing in, so we want to tell it which SOP has the volume for us, or the field. So let's open up obj tree, and there's my out temperature null. And we need to click plus to bring in a volume. It's giving us an error because it says you can't find one. So we called it temperature, so let's type in temperature. And it wants to know where we're going to copy that field to. So we're going to copy it to this target field, also called temperature. And you'll notice as soon as we do that, it brings it into the temperature field, and we can see it inside our display. This is a scalar volume, not a velocity vector volume. So if you're bringing in velocities, you'd want to change that to vector. So now if I press play, the box resizes, but then when the temperature comes in it, we'll see it goes up and sets the fuel alight, and the tree starts to burn. If I click on my Pyro node and back to the visualizers, or the visualization, I can turn off the temperature and turn back on the multi-field to see the effect of that. Let me press play again. Oh, let me go back to frame 1 and press play again. There we go. We'll see as the sphere comes in, it ignites the tree, and the tree bursts into flames. So that's kind of cool. And so what I'm going to do is just quickly play blast that just to see how that looks. So if I press play, we come in. It burns quite readily at the bottom here, but then it very kind of slowly catches fire as we go up the tree. I'd like that to catch fire a little faster. So I'll just stop the flipbook there. Let me just think about this for a second. So if we dive into the Pyro solver, this is where we can control how the how readily the flames burn. So what I'm going to do is click on the Combustion tab. This is where we can control the combustion. So the first thing we can do to control how fast it burns is this burn rate. At the moment that was set to 0.9. If I set this to 0.99 and just press play, we'll see that it burns a lot faster. Burns much more readily. So you can see it just inflames a lot quicker. But it doesn't tend to burn too much quicker up the tree there. Again, let me flipbook this to see how that looks, the initial ignition. So if I just press play, we'll see how little the sphere comes in. We get that extra puffiness here as it burns more readily, but then it still kind of slowly spreads up the tree. I'd like it to spread a little faster than that. So let me just stop that. I'm not too sure about this expansive nature of it, but we'll fix that in a minute. The other thing I can do to control this actually is the fuel inefficiency. Not all the fuel's burning straight away. So if we bring the fuel inefficiency right down, all the fuel's going to burn pretty much as soon as it's birthed. So let me just flip that again and show you the result. So basically what this does, it takes away a certain amount of fuel every time step. So giving it a much smaller number, it takes away a lot more of the fuel. and that should make it burn much more efficiently. Let's press play, it's burning, and you'll see it spreads a little bit faster up there. Other things we can do to speed that up is to bring down the ignition temperature. Let's bring this to something like 0.055. So that means the fuel's going to burn at a lower temperature. We can also increase the temperature here, say to a value of 1, and that will also get the it much hotter and make the fuel burn a lot faster. I'm actually going to bring the burn rate down to 0.90 before I flipbook this, because that can get a little bit out of hand if the fuel burns too much. So let's see what happens now that we've changed the fuel inefficiency. We've made it more efficient, burns at a lower temperature, and it emits a much higher temperature when it does in fact burn. So this should encourage all the fuel to burn a lot faster. And you'll see it does indeed. As soon as that ignites at the bottom, the whole thing just starts burning and burns very readily. And because we're producing a lot more temperature, things are raising up a lot faster. I kind of like that. Now that expansive nature at the beginning here, it kind of puffs out a bit. That's down to the gas release. The gas release causes, when it gets hot, causes gas to puff it out and increases the pressure, and you get this more puffy look to it. What I'm going to do is just bring that down to about a value of 3. So with a value of 3, if I press play, you'll see it's a lot less expansive. It doesn't expand as much and puff out. So let me go back to frame 1. Let's put this back to 14 again for a minute. If I look at it, it doesn't really burn very readily because there's not enough fuel at the minute. I'm going to just increase the fuel on that. So let me go back to this source fuel volume, and I'm going to increase the scale to 3. This will give us a bit more flame to work, bit more of a body to the flame to work with. There we go, because I want to see a lot more flame on there. And now we can really see the gas expanding, working to the max. So let me drop this back down to 3 again, now that we have a lot more flame. And you'll see it's quite a big difference when it initially comes in. It doesn't puff out so much, but we get that initial whoosh as it burns, and then we get the nice heat coming up and burning the tree. Let me flipbook that so we can see that moving in real time. I'll just pause the video while we get a few frames. Now I've flipbooked a few frames. If I press play, I've got the nice speed and frequency there, and you can see it gets very hot and burns very fast up there, and the heat rises a lot. Cool. I still feel it's rising a little quick, so we'll bring the temperature output down a little bit. So again, I'll just flipbook one last time. And you can see by slowing down the temperature, we get the nice initial whoosh at the beginning, but look, the flames spread slowly up the tree. And that you're going to be doing a little bit of toing and froing, but as you adjust one of these, it balances off another one, and you've got to work between them to eventually get the look you like. So I'm quite happy with the way that that's moving. So let's talk about adding a bit more detail and shaping to it. I might just increase a little bit more of the fuel to give it a little bit more body there, but we can bring that down a bit later on. So if we click on the Pyro solver node here, we've got these various tabs. Now the first thing I want to talk about is the simulation tab. This is what's interesting, is this temperature diffusion. If I turn on my temperature visualizer and I press play, we can see our temperature field there. If I click on the diffusion though, this is kind of a blur. If I press 1, you'll see it blurs out the temperature field. If I just go forward a few frames now, you'll see the temperature field's really blurry and blobby. So we don't want that. If I go back to the default value by right-clicking, revert to defaults, we'll see it's about 0.5. It was about 0.06 when we started in this scene, but I like to bring it down to about 0.2 or 0.1. It should just be slightly bigger than the voxels that you've got, so you don't see the stepping in the voxels really. But those values are quite good. Look, with quite low you can see you're getting a little bit of blockiness there. So if I put it to about 0.3, we smooth that out slightly because this is slightly larger than my voxel size. So it's a good thing to keep an eye on, especially if you want the details in your velocity fields, which we do. So I'm going to leave that quite low. If we come to the shaping tab, you'll see that there's various shaping elements on here. Let me put this back into wireframe. Let me turn the visualizer for the multi-field back on. So in the shaping tab, we can kind of control the overall simulation. If I just turn these off, you'll see this is what the actual raw simulation looks like. It's very smooth with mushroom cloudy kind of look, the smooth edge, domed edge of things that go up. That's the overall look of the simulation. Now the shaping tab, these don't really change the simulation. They think of them like filters. They kind of just adjust and warp the fields that you tell them to, based on other fields that you tell them to, in order to change the look. But you get the overall motion, shape and frequency right first. So the first one we'll look at is dissipation. This is set up using the temperature field. And what this does, this will dissipate the density for us. We don't have much else control over that. That just means it will fade off the density over time as it cools off. So your smoke will fade away. We'll look at smoke in a minute, so I'll leave it there. The next one is disturbance. Now let me turn on the velocity field here, and then we can see what's going on in the velocity visualizer. If I step forwards a few frames, we'll see our velocity visualizer there. If I click on the velocity tab, let me just change it to the YZ plane, and I can drop the streamer length down quite small so it's easier to see what's going on. Let's turn off the multi-field for the minute. So what you can see here is the velocities are very, very smooth, and that was that blobby simulation. If I turn on the disturbance though and press play, you'll see that we get noise everywhere, and it starts to break up the simulation. Let me switch the visualizers again. And you'll see we don't get so much of a domey cloud, a little bit of one, but it's a bit more broken up, especially at the initial beginning here. And we've got some controls that we can do with that. And the disturbance is great for adding these kind of noises. We can control the disturbance from down here. I'll come back to this disturbance in a minute. Now the shredding, what the shredding does, it shreds the velocity field for you, or the temperature field, whichever you specify. So what do we mean by shredding? Well, on the shredding, we either can squash the velocities or stretch them, and that's based on this temperature. Any values higher than this temperature, that will squash the velocity, and anything cooler, it will stretch it. So as the flames cool down, they'll get stretched, and this creates those nice licks that you see. Let me just put this up a little bit higher, something like 0.3. Let's have a look at that. If we have a look now, that should create a little bit more of the shredding effect. It's quite hard to see unless you've got some very nice velocity fields to start with. You see we should get some more bits tearing off there. We don't get so much of that mushroom or that smooth look at the top here. Let me just flip back this quickly and show you what the shredding does. It's a very good one, this one. So if I just press play there, you'll see it really starts to break up that smooth look, and we get at the top here little bits tearing off and moving around. And this is quite a good one to start to get that initial flamey and those licks. So what I'm going to do is I'm going to increase the temperature threshold here. So what that's going to do, that's going to encourage more stretching than squashing. So as this cools down, values higher than this will squash it. So we're allowing more values to do some stretching. In fact, I want quite a bit more stretch. So let's just put this to 0.8. I'm going to bring my squash down to 0.5. I don't want it to be so much noisy down at the bottom, but I want it to stretch more and pull bits off. So let's quickly see the result of this. So again, if I just press play while that's happening. Again, we get that initial dome. We'll fix that in a minute as the temperature goes in there. But as the flames filter through, you'll see we're getting not so much of that squashing, but we're getting much more elongated bits being torn off, which I quite like. But again, you can play with that. It's quite a creative control, and you can adjust that depending on what you see your references doing. Because I've stretched them, it has made my flames a little longer. Let's just zoom out a little bit to see that. Excellent. So what I want to do now is add some microsolvers. Now the microsolver I want to use actually is this disturbance, because we can get a little bit more control. over these things. These are all microsolvers, and you can find out what they are by diving inside the Pyro solver node. If I double click inside and zoom into this section, you'll see that we have our turbulence and our shredding, and there's the disturbance, and this is called a gas disturbance microsolver. If we come and have a look down, we can see that they're plugged into this plug on the smoke solver, and that is the velocity update. So if we go up one, we'll see that there's a velocity update on the Pyro solver because it's just wrapped around those other nodes. Let me move this out of the way. I'm going to pop in a merge node. I'm going to plug that into the velocity update. So now I can add my own microsolvers on top of the ones in the Pyro solver here. Now in this interface, some of the settings are hidden from you, which is why a lot of people prefer to make their own at this level. It doesn't really matter, we're just adding them in and mixing up that velocity field more and more. So I'm going to want to add a bit more noise to this at different frequencies, and it's the gas disturbance is my favorite one to do that with. So I'm going to hit tab and type gas disturb to create my own custom gas disturbance. Let's plug that in. If we just go over to the Advanced tab, I'd like to turn on Use OpenCL so we can take advantage of the graphics card. So how does this work? Well, in the Bindings tab, we'll see there's two fields here, the density and the disturb field. So we're using the density field to disturb the temperature field. Let's have a look at that in action. If I turn on the visualizer here for velocity and step forwards a few frames, we'll see that the velocity is stirring up. That's because the temperature is stirring up, and that will create we'll see the motion in the velocity. Just to prove that, if I turn the disturb off and press play, we'll see that the velocity fields are nice and smooth. So this is just moving the temperature field using density, and it does it through the disturb settings here, and it's mostly this cutoff. The cutoff is basically values of density below this will cause the disturbance, and above this will not. This is designed to work where the areas are thin and stir up your smoke, but not where it's dense. I'm actually going to I don't want it to behave like this, but I want to use it to create noise to my flames. So I want it to happen where it's hot, not where the values are low, but where the values are high. So I'm actually going to make the cut off at 1, so it's going to work through all the fields. I'm going to change the fields in the bindings. So the fields I'd like to do first of all is change this disturb field. If we click on the drop down, I can change it to velocity. Now velocity is a vector, so we need to turn this on, and I'm actually going to use the let's have a look at the burn field to control it. So with a threshold, a cutoff of 1, so basically wherever there's burning, it's going to disturb velocity, and it's going to disturb it by this amount, 0.75. So what is the burn field? Let's just have a quick look. So the burn field is where the fuel gets hot enough and the reaction happens. Oh, let me turn the multi-field off. And it's where the actual burning occurs. If I just turn off the ghosting so we can see the burn field. There it is. You can see it's this white stuff, and as it spreads up, you can see where the fuel's actually burning. If we click on the burn field tab here, we can increase the density and see it a little clearer. So basically this is where I want the disturbance to happen. Let's see how that might affect it. So let's turn on the velocities and press play. Oh, let's turn on the velocities. I'm going to increase the disturbance up to 1 so we can definitely see an effect. And if I press play, we'll see it's happening everywhere. It's because we set the threshold to 1 there, the cutoff. Let's bring this down a little bit, something like 0.8. So you'll see it's definitely disturbing everything, and we're getting this nice noise from the heat. And we're getting this sort of nice noise. If I put the, just look at the visualizer, you see it's really, really stirring up and creating this phonetic noise. Now if we look, we can see that we have these kind of squarish blocks, and the noise patterns are quite large. That's controlled from the block size here. Let me make this small. I want smaller features. Let's try something like 0.05. And you'll see we get much smaller features happening. And let me turn back on the density field, and it looks a little nicer as we're breaking that all up. Let me turn the ghosting back on. There we go. We can see we're sort of breaking up the smoke and creating sort of these nice edges on the disturbance there. This looks really good when we add a bit of shredding into the equation, because the shredding stirs up the velocity field with it. And we can see how that looks if we press play. So what I'm going to do is I'll just flipbook this so we can see the overall speed and motion of that. So there we go. If I just press play, we can start to see it coming up, and you can see we get this real twirly, swirly sort of motion going on there, and it's very, very noisy as it goes up, and it keeps getting noisy as it goes up a bit. And I'd like a bit more control over this. I'm feeling it's just overall a bit too noisy. So how can we get further control over these guys? Well, we can use another fill to affect how they work, and we can do that through the control settings here. Let me turn this on. I'm going to use the temperature field because I only want this to happen where it's really hot. So temperature, there we go. And so it's going to use the temperature field now, and it's going to half affect it. Let me turn on the velocity display again. So we won't see much of an effect yet. What I want to do is actually turn on 100%, so 100% of the temperature is affecting it. And I'm going to turn on remap. So here at the coolest temperatures, it's not going to have an effect at all. And at the hottest temperatures here, we're going to see the most effect from our disturbance. So if I press play now, we'll see only in the hot areas are we getting the disturbance, and here where it's 0 in the cool areas we're seeing nothing. Now if you look, we've actually got that smooth leading edge back again on the flames, that smoothish one. It's broken up a little bit, but it stopped that the noise out here, and it gives us quite a different look. So we can fade off or bring in how strong it is, the effect, by using this ramp. We also really want to set this range to be correct for the temperature, because at the moment that's between 0 and 1 temperature, and I don't really know kind of what temperature we're dealing with. So for that I can use the temperature field again to work out what values I might need. So in order to do that, I'm going to click on the temperature tab, and here's the range. So this is set to 1. If I lift this up, let me go to wireframe so we can see the colours clearer. If I lift this number up, we can see we're peaking off at white here now, around about 2 or 2.1. If I set this to something like white to red, it's the red areas are the higher, so maybe about 3 in some areas. So that's kind of our temperature range, 0 to 3. Let's put shaded back on. So we want to put this to kind of about 3, and that will just remap the ramp a bit better and give us a little bit more control. Let me turn the velocities on again over what's happening, and you can see again it's still very hot where the temperature's hot. It's disturbing the velocity a lot, and then it's still smooth at this leading edge. I might want to break it up at this leading edge a little bit. So if I click on this icon, I can make the ramp a lot bigger. And let me come down here. I'm going to lift this value up a little bit. So we're going to get a little bit of disturbance in the air around that leading edge, and that will break up that smoothness for it. So let me press play again. And you'll see we're getting twirling velocities just at the outer edge here. And look, it's broken it up a little bit. If I come in and just lift this value up a bit more and press play, you'll see we're getting a little bit more swirl around the edges there. And again, we're breaking up that edge a bit more. It's not giving us that kind of domey look so much, and I kind of quite like that now. Maybe I'll leave the settings at that. Let me turn the visualizer off. And you see we don't have that sort of smooth leading edge there. It's looking much nicer. So now I'm kind of quite pleased with that. I'll just do one last flipbook just to make sure the speed is right, and then I want to add some more of the disturbance at different sort of scales of noise, at the different block size basically, just to add a little bit of more complexity into our flame, especially for when we add those high resolutions in. It'll add a bit more detail. So I press play now. We can see it's happening there. We're getting this nice sort of disturbance as well as the shredding, pulling bits off. It burns quite readily, but then we see sort of the flames spreading up, and I quite like that. Good. So now that I've done that, I'm actually going to hold down Alt and left click with the mouse and drag that node out to make a copy. And let's go to the disturb settings. So at the moment this is a block size of 0.05. Let's make a much smaller noise, and I might also make a bigger one. So 0.05, let's do 0.1 maybe. So we've got a range of scales here. We've got 0.05, 0.02 and 0.1. So a large one, a middle-sized one and a small one. To preview this, I'm going to click on the Pyro node, and I'm just going to come up the top and maybe bring my resolution down a little bit more to 0.1. To do one last flipbook to make sure I like what I see for the speed and the motion and stuff. So what I'll do is I'll just pause the video while we flipbook that. Now that flipbook has occurred, it took a while because of the increase in resolution, but I can see it was worth it. We got that nice sort of explosive catching on flames. We can see the flames slowly spreading up the branches, and we're getting these nice licks at the top. And you can see my disturbance at the different scales, adding a lot of interest and a lot of different features and bits happening with the flame. So this makes, I'm quite happy with that. I'm liking the overall motion. So the last thing I want to do now is think about adding some smoke to this. I'm just going to increase the resolution for speed. Let's try 0.02 again. And let's talk about adding some smoke to it. Because when this flames off, I want to see a bit of smoke emitted. Now there is already some smoke being emitted from the simulation, although we just can't see it with the visualizers. And of course we can shade it however we like later on, so we'll be able to see that. So let me just play forwards for a few frames. Let me just stop it there. And I'm going to click the smoke object node. Now in the multi-field here, we can preview the density. We can do that in the smoke tab. So first thing I'm going to do is up the density scale to something like 3, and you can see there's a bit of it coming in. We can also put the shadow scale up to 3, just adds a little bit more contrast, or not too much in this case because it's not very dense. To make it more dense actually, this is the density field. This is how transparent it is. And again at the left hand side here, this is the 0 voxels. If I actually put this up to 1, we'll fill all of those with smoke, as you can see. Not quite the effect you want. Let's put that back down to 0. Because we don't want we want empty space to be 0, but these are the values, and across here is the value of the density in the field. So if I want it to be heavy smoke, I want it to have a sharp drop off. So I can just give it a sharp drop off at the end here like this, and you'll see that gives it a much thicker density. It looks much more heavy. I think that's probably too heavy for the kind of smoke we want. I could bring down the density scale a bit and sort of get that puffy heavy smoke look. Look, the shadow scale really kind of works now. If I bring it down, it's kind of flat, diffuse smoke. But if I put that kind of heavy, you get more contrast, and just suggests it's a bit thicker than it actually is. This is a nice trick just to suggest that the smoke's thicker without actually making it thicker. I quite like that actually for rendering for the look of the smoke. But what I want to do now is, and we can also tint it actually with the diffuse field. Let me just copy density here into diffuse field. And now we're using this sort of black and white ramp. So again, where it's thin, it's getting darker, and where it's not so thin, it's this white color. I'm actually going to select the black here. Let me make that still white. I'd rather it fade off than get dark. In fact, I quite like the whitish look there. We'll stick with white actually. I'll come and tint that a bit later on when we shade it. Cool. So the other thing is actually this dissipation will now work. You know, the longer we play that, this smoke will fade off over time. I don't really want it sort of hanging around. I kind of want it to fade off a bit quicker than that. So let me put the dissipation up to, well look, if I put this up to quite high, 0.6, you'll see as the smoke comes in, it will disappear fairly quickly. So we're getting those little puffs again. And you'll see they're kind of just disappearing. We're not getting the volume that we were seeing again. We're getting these kind of little wisps at the end, and it just disappears quite fast. 0.6 is too much. Let's put that to something like 0.2. And that'll keep some smoke hanging around for us. If we go to the solver node, actually, to the combustion tab, we can click on smoke here. If I actually turn off emit smoke, it won't emit any. If I turn on create dense smoke, it will create a much thicker amount. Let's increase the amount as well, and now we'll get huge plumes of really thick smoke coming off. So it starts getting dark a lot earlier, and we're getting a lot more deep clouds appearing out around here. So a lot more density of the smoke appearing. So let's turn that off again and bring this back to 1. I want it quite light smoke because there's not a lot really burning. If it had a lot of green leaves, we'd expect to see a lot of smoke. We can also control where the smoke is emitted by this heat cutoff. So basically, as it cools down, any heat values below this is where the smoke's generated. If I put this up quite high, then we're going to get smoke almost instantly from all of our burning. So as soon as we come in, you'll see we get a lot more smoke down at the bottom again, quite like having the dense smoke, but there's quite a lot just coming out from everywhere. If I make this value very, very small, then we'll just have a very little bit of smoke just appearing at the very ends of the flames. So remember, it's still cooling down here, so we see some smoke, but look, not as much. We're not getting that huge density we got down at the bottom of the tree here. But we're getting a little bit coming off at the ends there. So you can really control sort of where you start seeing the smoke and how much you start to see. I'm going to have quite a small cutoff, but I'm going to increase the density without making a dense smoke. We could also use the burn field instead of the heat field. Oh, I don't know if you just saw it there. There we go. As the cutoff amount in order to create our smoke for us. So let me see if this creates a nice little bit of wispy white smoke just after it cools down a bit, but then that should dissipate a little bit. It's just to suggest burning off the moisture in the wood, and then it kind of evaporates off a bit. So there we're getting some nice sort of puffy smoke coming off it, and then hopefully that should start to dissipate a bit. That's not too bad. Might just increase the dissipation a little more, and then as always I'll just do one last little flipbook to check that, and then we'll talk about rendering it. So let me just run the flipbook, and I'll just pause it for one more second. So the flipbook is complete, and I took the liberty of actually flipbooking it at a slightly higher resolution, so we can see all the details in there. And again, we still have the nice sort of catching flames up this branch, and slowly the flames are spreading up the tree. But we can see we've got nice noise, and the smoke's sort of dissipating off at a good rate. Kind of got that smoky edge to it, but I didn't want it hanging around. So that feels really nice. I sort of like the way my tree's burning. The last thing I actually want to do is not have the whole tree burning. I'm going to go quickly and fix the emitter, so just the base isn't really burning and it's not so uniform. And then we'll talk about rendering. So in order to quickly adjust the emitter, let's pop into the tree network. So at the moment we're creating points all over the tree, and if we have a look at how many points we're creating about 8,000 of them. So we can create our own points by using a scatter node. So if I drop a scatter in, I can create my own points on the surface, and we can also create 8,000 points. I'm actually going to turn off the relax because it looks slightly better if they're a bit more random. Now the advantage of using the scatter is we can actually scatter by an attribute here. We can give it any name, but we'll use the name density. If you hit tab, you can type paint, and you can use the paint SOP to actually paint that density value in. If I turn on the paint SOP, I can, where are we, scroll down here, we can override the color with density. Now if I select this node and hit enter with my cursor over the viewport, I'm not seeing the right colors. If I tap W for wireframe, I'll see the correct colors. Now the purple means 0, and if I left click and drag, I'm painting this value here, which is 1. So that'll be my density value. Now there's a slight quirk with this version of Houdini. If I click on the scatter SOP, oh, it does work actually in this case. Sometimes it doesn't work, and you have to click back on the paint SOP to redraw. But in this case, you can see it is working, and it's just putting the points where I've painted. So I'm going to paint on my tree where I want it to burn, really. So I'm going to paint on the branches. I'm not painting everywhere. Some areas may not burn, or I just want to create, again, just break up the initial bit here. And I might have to play with some of my fuel settings when we go back into DOPS. Let's see how that looks. So if we look at the scatter, there we go, that's a nice sort of a randomish area. Let's just maybe paint a little bit more there. That looks kind of good. I want a bit more definition on these branches. Something like that will do. So we can now plug that into our fuel, our source fuel. But if I turn this on, you'll see it's not working. That's because we're scattering on a surface up here, and we don't want to scatter on the surface. We don't have a surface, they're points. What we want to do is actually keep the input. So if we keep the input, you'll see it just passes those points straight through. If I turn on the out fuel, you'll see if I hit W, so we can see it in shaded mode, there's the fuel representation of our tree. Excellent. Let me display the tree again. So I'm going to go back into the DOP sim. I'm just going to increase the resolution of this again, just so we can see the effect of that quickly. So when I press play again, you'll see that the tree doesn't burn all the way from the base, and it doesn't burn all the way on the branches. It's a lot more broken up. And because we haven't got so much fuel coming in, I might just need to increase those values. But let me just see the sim evolve a bit more, because let's wait for it all to catch fire. So that looks alright. Let's just again see it in real time. So I'll just do a very quick flipbook. So there's a problem with simulations, you're constantly having to flipbook them to see them moving in real time, to make sure it all feels right, it's the right kind of scale and motion. So there it is, bursting into flames, and then evolving through. You can see some areas are catching flame again. Maybe not as much as before. I could go back and paint some more on there, but I'm not going to. I quite like the way that's broken up there and catching on fire. Excellent. Okay, so the next thing to do now is, once you're happy with that, I'm kind of happy with that, is to cache it up in order to render it, and then we can talk about rendering. So before I do that, I'm just going to add a little bit more fuel into the equation, just to give us a bit more body of flame to work with. So to cache this up, what you need to do is you can do it in two places actually. You could either go to the bottom of the simulation and cache it out from here. This gives you a lot more data, but the advantage is you can resimulate from any point and reuse that simulation data. But if you want to put less data on disk, or you're 100% happy with your simulation, you can cache out from the Pyro import node here. So this brings the simulation back in. This node here, the DOP import, the visualization, brings it directly from DOPS, whereas this node does as well at the minute, but this is one we can use it to cache out to disk. I'm just going to turn the cache off from the previous example. If I actually display this one, you'll see it's just a bunch of white fields, and it's the fields, if I click on the import from DOPS here, that are being done. And you can see from the previous example that we've turned off the two rest fields, the fuel and the color field, because we don't need those. For shading Pyro, we only really need heat, temperature, velocity, and density for the smoke. So those are all those guys. What I'm going to do is write out the cache from here. But before I do that, I'm just going to increase the resolution. So let's go back into here and just drop this down a little bit smaller. Let's go back to frame 1. And then in the DOP import node, you must save your scene before you save this out in the background. The other thing I'm going to do is just turn this button on, compute min max values. What that will do, actually, if I step forwards a couple of frames, when the simulation starts, this will compute our certain temperature and heat values for us, so we can use that for the shading. Let me just jump forward to the simulation actually starts. There we go. So if I click in the geometry spreadsheet, if we select this guy, you can see it's bringing in these fields, and if we look on the primitive attributes, you'll see here's the name of the fields and there's their maximum values. This will be really useful information to help us with the shading. There's a few ways we can find that information out, and I'll show you those in a moment. So now that I've set the high resolution, and now that I've saved my scene, I'm going to go to Save to File, and I've got a location for it already. So you can click on the browser to drop a location in. I'm only going to write out 150 frames, and I'm going to hit Save to Disk in background. So I'm going to pause the video while that happens, and then we'll come back and look at the shading. That's finished caching out, and I'm going to turn on Load from Disk. Now when I do this, I want to make sure I'm not displaying anything from the DOP network, so I'm making sure that this node is not visible, and you can do that by clicking or control clicking on this right hand flag. So we're just displaying this node. That means I can jump to a time here and it's not going to evaluate the DOP network. I could turn off the DOP network as well, but it's not necessary in this case because I'm not forcing it to display. And there we can see our fields there. It doesn't look very good, but we're going to render it to make it look a lot nicer. Let me look through the camera for this actually. Actually, we had a better angle before. No, I'll look through the camera. So let's zoom out a little bit. Just lock the camera. I will revolve around to a slightly better angle. So yeah, we can add visualizers really to kind of see how this looks, but or we could render it. Now there's a couple of things we can do. As I mentioned before, we can click on the geometry spreadsheet and we can see our max and min values here. So we're looking at the heat is about 19 and 12. We can also get to these values in other ways. They'll become useful in a minute when we come to shade it. If we create a volume slice node, volume slice, we can sample a thin section of the volume here. Let's turn this on. At the moment it's sampling everything, but up here if we choose, we can actually choose the heat field. I'm actually going to copy this name and put it here and call the node the same thing. The reason is this is going to create a point attribute on these points for the heat field. So if I look in the spreadsheet now and click on points, you'll see we've got the heat field here. If I click on the top, I can sort the list out, and you can see also we have about 13. If I click on the import fields node and look at the heat here, that says about 19. You'll notice there will be a slight difference. The thing is, we're only sampling a thin strip and a few points in that thin strip compared to, on this guy, the whole field. But it gives you, they give you a rough idea of the numbers. If I actually increase this up until it peaks out, you can see only at the hottest areas are about 7 here. We can slide this through the volume, and we can see where the hottest areas are. So probably 1 or 2 bits are peaking up at 13, but mostly it's about 7. So this is probably a better idea of what's going on. We can also do the same for temperature. If I make a copy of this by Alt left dragging, I'm going to actually delete the field here and choose this time temperature. Let's copy the name again. Let's Control C, Control V. And again I can run the temperature through, and let's have a look down here, and we can see that's just as hot. So again, if we pull the values around, come down, we can see the temperature lives sort of around the 4 value. So this is around, the heat tends to be around 7, and the temperature in this case, let's display the temperature, is around about 4. So those are the hottest areas. There we go. If we go to the where the fuel's the most. So something like that gives us an idea of these numbers. Let's put that back to 4. Now remember, we want to render this node, so let's display that. So let's render it. We set up a mantra node before. We've got a nice quick one to render. If I just go to the out context here, I can just check the settings on that. So again, we'll just bring down the pixel samples to 2 and make sure everything's at 0 here and the limits are pretty much 0. This is just for speed, and I'm going to override the camera resolution to speed things up. So I'm going to click on the render view, and I'm just going to open up these top and bottom bars just by clicking on them. That's so I can rehome the view and also adjust the exposures down here. So I'm going to click render, and I'm actually going to turn off here the progressive display. So I'm not a big fan of it. I like the tiles to render entirely. And it takes a second or two to load in that rather large volume. And we want to click on the Material tab here. And we can click on the Flame shader. This is the shader that's actually going to colour our volumes. And we've got a rough idea sort of for the numbers that we need. It was about 7 for the heat and about 4 for the temperature, according to what we were looking at in our volume slices. So if we render now, see it renders fairly quickly. It's rendering under my cursor because I'm left clicking in the viewport there. And it renders very quickly, and we get a sort of nice idea of what's going on. I'm actually going to hold down Shift, left click and drag to make a region here. So the first thing I want to do is set up the shader a bit more correctly. So I'm going to go to the fire intensity field, and correctly it's run by the heat field, and our temperature field is run from the temperature. Now in the intensity field that we're using the heat for the brightness, I'm going to turn on fit range because I actually want to set this to the ranges that we saw in the volume slice. And this was about 7, wasn't it, or 6, something like that. Let's put that to 6 and see the effect on the image here. It's important we get the ranges in so that the other things work correctly. And you'll see we've stretched out all that brightness, and we can see a lot more detail, but it's not looking so bright. If we go to the fire temperature, let's turn this on, and this is about 4. So let's see what that does once we bring the range here. So what this range does, if we go to the General tab, it controls the color mode. At the moment we're using a natural black body ramp. Now it's gone a lot darker because we're actually scaling the temperature at this point. Let me put that back up to 1, and that'll just rescale the ramp correctly again. So on the black body curve, 0 is at the left end, the black dark end, and then it goes through red to yellow to white, which is up at the top end of our temperature range here. So the values of 4 will be peaking out at the top of this black body ramp. You can sort of get a nicer idea of what's going on there. If these numbers aren't right, we can always adjust them. So look, I could always bring this down a bit and sort of make more of these mid values much more brighter in the ramp. And also in the temperature field, we could bring that down, which will also make the mid areas brighter in the ramp. So we can really customize and control how this looks. Now there's another little thing that I like to do for adding detail to my flames, and that's turn on the lookup ramp, particularly for the heat. Now let me make this a little bit bigger. Now again, this is where the heat's 0 and this is where the heat's the maximum, and what I like to do is flames, when they're really hot you can't see them, and then as they cool down they start to come into the visible spectrum. So what I'm going to do is just pull the mid values up, and I'm going to clip sort of the hottest points here. Now if we look at the white areas here, if we just wait for that to kick off on the render, we'll see we get a lot more detail, see a lot more things happening as we're punching holes in the flames here. And this is a great way of adding contrast and detail to your flame. You can move the midpoint around. You can either make sort of the hotter areas brighter and more of a drop off, sort of those midpoints, or you could also make the darker parts of the ramp brighter. So these are the more orangey areas brighter, and you get more of a fall off at the top. So you can really control sort of how the kind of the look that you want here. You can also move the ramp up. If I put this higher, then we're going to clamp only just the top values. And if I bring this too low, then we're going to clamp nearly all the values in brightness there. So you can play around with this to kind of get the contrast and the look that you want. So this looks kind of good for me. I'm seeing a nice bit of detail here, and it's cooling off nicely, getting to this orange colour there. Excellent. So that's quite a nice looking ish render. Now I want to see the smoke. Let me just stop this for a minute and look back through my camera. Just lock the camera and zoom out a little bit more. Now I'm going to go forwards towards more the end of the simulation there. Only rendered out 150 frames, so let's go to frame 127 and we'll load that in, and we should see some smoky bits at the top of the flame here. Now in order to see the smoke more, I'm going to increase the density scale like we did before. So let me hit render again. Now remember, we've gone through the simulation a few more frames, so we should start to see a bit of smoke appearing here. So we'll just have to give it a second so it translates the scene. So we can adjust the density scale here, and if we want to adjust the fall off like we did in the visualizer, we can do that in the smoke field here. Particularly we can turn on the fit to range, use the lookup ramp in a minute, and draw in that sort of steep curve to get that more dense look. As again, if we just run through, and just see some of that render, we can start to see the smoke as this dotty stuff here. So I'm going to turn on the ramp and give it that really sharp drop off at the edges here like we saw before to create some thickness to it. And you see that's really sort of created sort of this mistiness which is reflecting the light that we have in the scene. So I've made that a bit more visible now. So again, we can come down here and tint the colour with a colour ramp, or mix in CD. Now we also have this scattering phase. If we put negative numbers, we cause some backscattering, and this adjusts how sort of the light will penetrate through the volume there. We haven't actually got the samples on, so we might not see it too much. So here with the backscattering, all the light's getting reflected back, and the smoke is really, really dense. And let's have a small negative number just to make it a bit thicker. And as we bring that, oh, wrong one, as we bring that down, it just gets that bit darker. As we're scattering more back into the volume. And if we put positive numbers in, we get forward scattering. So you can control sort of the brightness of your smoke with that phase there. This is kind of nice. I'm going to make this actually a lot brighter, the heat. Let's hit 15 to make that a lot hotter. Now there's a couple of other things we can do, particularly with the color temperature here. At the moment we're picking sort of the mid-range of the black body ramp, and we can make this appear hotter, so these orange areas sort of whiter and these yellow areas more whiter. By increasing the color temperature here, this will make it appear as if it's burning a lot hotter. The dottiness is down to our sampling issues, sampling, which we'll talk about in a minute. So we can see the tree really looks like it's on flames, and we get a nice heavy smoke off this. You'll see with the higher color temperature it's burning a lot hotter and a lot whiter. So if I actually put this up quite high, you'll see it'll burn even brighter, although I quite like 6000. So look, even whiter down in these areas. Now what's interesting, if I adjust the exposure and bring it down, you'll see we still have all that detail in there. I'm going to put this back to 6000. We can also adjust the adaptation. That affects the lower end of the ramp, and what I mean by that is where it goes from this sort of yellow to this orangey colour. So by bringing this down, we can make that less contrasty. So if we just have a look, you'll see it's a lot less contrasty. We don't see that gradient so much. And if we put higher values, we increase that and we make it much more exaggerated. Let me revert that back to the default, just so you can see the difference in this area. So if you want it to appear a bit brighter, a bit more orangey, you can adjust that. So I'm just going to increase that a little bit, because I want to see a bit more of that oranginess in the flame. Something like that's good. And then that affects the bottom end of the ramp, and then this burn affects the top end of the ramp. If it's burning out too much, you can sort of put negative burn in there, which will take away some of that brightness at the top of the ramp. Again, it will fade off the contrast there. So we're getting, put it in there, less sort of harshness in that brightness. And if you put it up high, you start clipping, and you'll get more harshness in your brightness, which probably in this case we don't want. So I'm going to put a little bit of negative burn in there, just to keep the brightness but add a bit of detail in. Let's reduce that burn. I want a little bit of burn out here as well. So you can really sort of fine tune the detail and the contrast in your flames here. Remember, this is low res as well, so sort of half res, and we can still see a lot of detail now happening and a lot of interest. So what we want to do is put this in an environment and see what happens if we have a proper floor in there. So I'm going to control click on a grid, and I'm just going to scale that up about 10 times, and let's pop a geometry object in. I'm going to pop a sphere in and have this sort of behind this guy. Let's put this to 0.5, and let's drop another sphere in, bring him in the foreground, and also put him up so he sits on the grid there. So we've got a guy in front and a guy behind sort of our flames here. Let's go back to the render view and hit render, just so we've got some more of an environment in here to see how this might work with other bits in there. So I'm going to go to the render settings while this happens. I'm going to press on this button here, and that will bring up the mantra settings for us in a floating window. That's this button up here at the top of the interface. Because in a minute you'll see that we don't really have any indirect lighting. We're not bouncing light around the scene. So if that just starts rendering. You'll see we don't get any light bouncing around the scene there. Let's wait for the floor to kick in. So remember, we're illuminating these with a spotlight as well. So let me select my spotlight. I'm going to bring the exposure down to maybe something 1.5. So have a little bit of illumination from the spotlight there. As you'll see, we're not seeing the smoke so well, because it's the smoke that should be doing the illuminating of everything. And you'll see we're getting some light on our floor here, a little bit of orange, but we need some indirect lighting occurring. Now to do that, we turn these features off. We want at least one bounce, ray bounce in the diffuse here. If I middle click on the bottom, you'll see suddenly now we're getting illumination coming from our flames onto our surfaces here. We've got our sampling very, very low here, which is why we're not really seeing anything. If we put a volume bounce on as well, we should allow some of that light to scatter around, look, in our smoke, and we start to see a bit of the smoke here. I might put up my spotlight a little brighter so we can see a little bit of smoke in there. Let's do 2.2. So it's important to have these ray bounces so we can see sort of this indirect lighting, but as you can see it's very, very noisy. Now the way to fix that, let's put some of these quality values back up to 1, and also for the volume. If I had reflections and refractions, I'd turn those on too. So this will just add another sort of little level to the sampling there for the indirect lighting that we might get off this guy. Now where this really gets affected most is, as you'll see, it's not really affecting the, well, it's not affecting the noise much actually, because we need to put the ray samples up. Let's put this up to a value of 9. So now we're allowing these diffuse qualities to allow the samples to happen based on the noise threshold. So this will render a little slower, but you'll see that this noise is a little bit reduced. There we go, it's looking a little smoother. Now the way to get this looking nice and smooth really is to increase the pixel samples. If I increase them to something like 6, let's just zoom down into this area. That's the answer to sort of making these nice, making the light coming off the fire look nice in your scene. So I'll just pause the video while the render kicks off for this. So a few tiles have rendered. They've gone a lot slower on my humble machine while I'm making this recording, but as you can see it's definitely a lot smoother and a lot more improved. We could probably tweak some of the sample settings to speed it up a little bit, but this is one of the downsides. It is quite slow to sample it with all this nice noise, but you get a very, very nice smooth render happening out of that. So what I might do is just pause the video again and render this whole frame at full res at nice quality, just so we can see how that looks. So I'll just pause the video. So the rendering is just completing, as you can see. The last few tiles are doing, and it took a little while because the sample quality had to be raised a lot. I also rendered it at a much bigger resolution, and I need to still increase the sample settings here, as you can see. But if you were to render this properly, which I will do in a minute to see it animate, we would render this in layers. We'd render the flames separately and composite it later over the background. That way you could manage the sample settings and maybe render it a bit more efficiently. So just a note about rendering this. When we do render it, we want to create a couple of passes for it so you can composite it nicely. Let me just stop that and take a snapshot of this. So now the render's finished, actually, let's zoom in. You can see there's a lot more detail, and the smoke looks quite nice and quite smooth up here, and that should dissipate off quite nicely. But as I was saying, there's a couple of passes that we need in order to render this effectively. Now to demonstrate the passes, I'm just going to quickly bring down the samples again and just turn off the indirect lighting just for speed, and let's go back to half resolution. So you can find the passes, well, if you actually click on the shader for the Pyro shader here, if you click on exports, these are the name of the passes. We'll get two masks, one for the smoke and one for the fire, which is the intensity here, and these are great for compositing it in there. So to use these, we've got to remember the names here, so I'm going to Control C and copy smoke mask, and I need to go to my mantra node. So on the mantra node here, in fact let's bring up the floating one by clicking on this icon. That should bring up the floating one. Let's try that again. Oh, there it is. It's appeared off screen. That's so we can have this open at the same time. I'm going to click on the images section and then on edit image planes here. And I'm just going to click on the material tab and click on flames so I can see the name of the masks here. So we can add AOVs here, or arbitrary output vectors, or extra image planes as we call them in Houdini. And to add them, we want to add a custom one. So we can click a little plus down at the bottom here, and we can paste in the name that we want, smoke mask. And we want to give the channel a name as well, so we'll give it the same name so it makes sense. So So this is the name of the mask that the variable we're going to read from the shader, and this is the name we're going to give it when we output it. So we want those to be the same. The other most important thing is the data type here. This is not a 3-channel image, a vector. It's a 1-channel, a black and white image. So we want a float. Otherwise, it won't write anything out if you get that wrong. I'm going to click plus again, and I'm also going to make another float here. And this time I'm going to Control C and Control V, fire masking, and we'll give it the same name. So we have the smoke mask and the fire mask being rendered as these extra image planes. So to see those, let me just hit render, and we'll be able to get a preview of those. So we've got to wait for the scene to start rendering. There it goes. Let me just click on the home button here to center that. And we can preview these extra image planes up here in this little drop down here. And you can see it's now listing the smoke mask and the fire mask. Obviously we won't see anything until we start rendering some tiles. So I'll just give this a second to kick in. There we go, we're starting to see some stuff here, and we'll just fill in the outer edges by left clicking. And if I now choose, say, smoke mask, you'll see we can see this is the smoke mask in this channel, so the compositor can use this to sort of affect the smoke in the fire. And then we have the fire mask, so these are sort of the brightest areas. And then obviously we've got the color channel. So you want to be outputting these masks for compositing later, and you'd obviously render this on its own against black and split up your overall render. Now to improve the sampling quality here, we'd have to go to our mantra node, and we'd have to increase sort of these pixel samples to quite some high levels, and that would make the rendering take a very, very long time, because we've got some very bright intensities, and it's not great sort of this indirect lighting within Mantra. But there's another strategy we can do in order to render this quite quickly, and that's to use a volume light. So let me just show you how to use that. And the advantage of that is we don't need to use the indirect lighting, we can simulate it with volume light. It's quite easy to set up. We can use the shelf again. If we come up to the shelf here, this through the camera. If I come up to the shelf, I can click on volume light up here, and it asks you to select your volume. Oh, hello, it did it to the wrong thing. Let me just undo that. See, that's the problem if you have something selected in your viewport, in your network view. As soon as you hit the shelf, it applies to that object. So I'm just going to left click to make sure nothing is selected here. I'm going to click on volume light, and then the prompt says select the object for your volume light. I'm going to select the flames on the tree there. Oh, there we go. And let's hit enter, and it sets up the volume light. Now if we look at the volume light, we can the options, we'll see that it's an area light setting here, and it's set to use the material that's applied to this volume, and also it's going to bring it in the volumes within there and use that to basically scatter a point cloud and use that to sample the illumination. Now what's interesting about that, if we actually look at the Pyro import node, click on the render tab up here, and then in shading, at the bottom there it's turned off emission illuminates objects. So the emission from this shader now is no longer going to illuminate the scene. We're illuminating the scene from this volume light, and we can control the brightness as usual through the exposure, and the detail through the point samples. So let's have a look at how that might look, but before I do that I'm going to pop back to my mantra node. So let's click on out here, and I can click on limits. We don't need any sort of these indirect ray bounces at all, because we're simulating that with our volume light now, so we can turn all these to 0. That's going to speed us up a bit. I'm going to increase the pixel samples to 3, just a little bit higher, and yeah, let's put some of these settings back up to the defaults there. So let's click on the render view and see how this looks. So I'm going to just hit render there, and I'll just pause the video while that render happens. There you go, the render has finished, and that only took 1 minute and 30, and as you can see the sampling is a lot better. There's very little noise, and we're still getting that indirect lighting from the flames going on. So it's a much faster way to render the flames is using the volume light. I'm just going to put the ray samples up to about 9, and the last thing I want to do is to now render this as a sequence. So to do that I'm going to come back up here, turn off override camera resolution, and I'm just going to render the sequence. So I'll just pause the video while I render the sequence. So there, the sequence is rendered. So if I press play, we can see that flames up nicely. Our volume light's creating a nice sort of indirect lighting from the fire here. We've got the nice sampling, it looks nice and smooth. We can see that the fire starts when that hidden temperature comes in and it ignites, and the flames rush up through the tree, and we can see a nice bit of smoke appearing out the top here and just dissipating off. And we can see all the levels of noise that we put in using our disturbances there. So I'm quite happy with that. I'm quite pleased with the look of this. I hope you are too. And that's it for the end of the video, and I look forward to seeing you in the next one. Thank you very much. Bye bye.